Hello everyone, welcome to my channel Physics Tricks. So let's start with laws of motion DPP, and in this we have first DPP, and all the questions I'm taking over here is the theoretical one. And as you can see, this is the first question we have. Inertia is that property of body by virtue of which the body is. Okay, so see, firstly you have to understand what is inertia over here. Inertia is nothing but the inability of a body to change its state of rest, state of motion and state of direction. It is just the resistance to the rest. It is just the resistance to the motion. It is just the resistance to the direction, isn't it? So if you want a simple example, if you are standing in a bus and bus suddenly starts, what will happen? You will tend to fall backward. And if you are standing in a bus which is already moving and the driver of a bus applies a brake, what will happen? You will tend to fall forward, right? Why is so? It is because of the inertia of rest in the first case and inertia of motion in the second case. So I hope this is clear. So what is inertia? It is the inertia is the inability of a body to change its state of rest, to change its state of direction, to change its state of motion. So that is what the inertia mean. Okay, so inertia is that property of body by virtue of which the body is unable to change itself the state of rest, correct? Unable to change by itself the state of uniform motion, correct? Unable to change by itself the state of rest or uniform motion, correct? So the answer for this first one is all of these. So I hope this is clear. So though I am taking the theoretical questions over here, so all these questions are really very important. So listen to these questions very carefully and adapt it, right? So over here, first one answer is all of this. Now second one, we have a cold drink is kept on the balance. When the cap is open, then the weight, what will happen to its weight? Okay, so cold drink is there. So this is the cold drink supposed to be. Now if you just open the cap, what will happen? If you just open the cap, initially whatever the pressure is there now, due to the pressure, the force, the reaction force will be in the downward direction, and initially the actual weight of the this bottle, right, due to the reaction force. So this is the reaction force. Gas is present in between, right, in between these two, and due to the force of a reaction, right, due to the force of reaction, the weight of the bottle will increase, right? It is observed practically, so you have to believe this will increase, and once that pressure is equal to 0, or it is that pressure which is exactly equal to the atmospheric pressure, then what will happen? The weight of the bottle will decrease. So firstly it will increase and then it will decrease. So option C is the correct option for the second question. When the body is stationary, what does this mean? Stationary, the number of forces acting on the body is equal to 0, isn't it? So if stationary means what? If you apply 10 Newton force from this, 10 Newton force from this, upward, if 10 Newton force is there, downward must be 10 Newton force. So then this body, on this body, the net force is equal to 0 Newton, right? So there is no force acting on it. Wrong. There might be infinite number of forces acting on it, but the net force on it is 0. Okay, the forces acting on it are not in contact with it. The combination of forces acting on it balances is there. So that is what? The body is in vacuum. No. So option C is the correct option. There is no force acting on it. There is no logic in it. Second, the forces acting on it are not in contact. No logic. Third one, the combination of forces acting on it balances each other. That is what the correct answer is. Fourth question now. When a body is in translatory equilibrium. Translatory equilibrium means what? It is moving, right? It is moving, but with a constant velocity or else uniform motion, we can say. The body is definitely at rest. The body is definitely in the state of uniform motion. The body will be either at rest or in a state of uniform motion. Translatory equilibrium means what? It might be in motion. It might be in motion, but the net force on it might be equal to what? 0. Or else at rest, net force is equal to 0. So the either at rest or state of uniform motion. So option C is the correct option for this question. Now fifth one, a particle is moving with constant speed along a straight line path. The force is not required to. See, now a particle is moving with constant speed. Constant speed is there, right? Now force is not required to maintain its speed, isn't it? Decrease the momentum, it will require. Increase the speed, it will require. Change the direction, it will require. Keep it moving with the uniform velocity, not required. So object at rest, it will remain at rest. Object in motion, it will remain in motion unless and until external unbalanced force acts on that body, right now. So that is what the Newton's first law is. If F external is equal to 0 Newton, right? If F external is equal to 0 Newton, then object at rest, and if object is in motion, it will remain in motion. Remain at rest, and it will remain in motion. It will remain in motion unless and until external unbalanced force acts on it. That is what the Newton's first law is. Okay, so we have the particle is moving with a constant speed. That means the force will not required to keep its motion, right? Keep its uniform motion, we can say. So sixth question now. Essential characteristics of equilibrium is. What is the essential characteristic of equilibrium? Momentum equals to 0. Acceleration equals to 0, kinetic energy is equal to 0, velocity equal to 0. It is equilibrium means what? It is the acceleration that needs to be 0. Momentum might be 0, might not be 0. Kinetic energy might be 0, might not be 0. Velocity might be 0, might not be 0. But the acceleration must be equal to 0, right? So you can write for equilibrium, F external must be equal to 0 Newton indicates acceleration must be equal to 0 Newton per kg or meter per second squared. So same thing. Okay, so I hope this is clear. So all these questions are theoretical, but yes, these all questions are really very important. So for sixth one, it is the option B, which is the correct option over here. Now the next. So seventh question, when a constant force is applied to a body, it moves with uniform what? If you apply a force, it will move with uniform acceleration. Velocity will increase, speed will increase, momentum will increase. It will move with constant acceleration. Okay, now ratio of force and acceleration. We know that force is equal to mass times acceleration. If force is applied, acceleration will be there, right? If force is applied, acceleration will be there, right? So the mass is equal to then force by acceleration, and they are telling force and acceleration ratio will be the mass, but they didn't give anything mass over here. So answer is D. Passengers sitting in a bus are thrown outward when the bus takes a sudden turn. This happens because of inertia, we can say, right? Inertia. And what is that inertia? Inertia of direction. Inertia of direction. When we kick a stone, we get hurt. Due to which of the following properties of stone does it happen? It is due to the inertia only, right? Inertia of rest, right? That the stone doesn't want it to come into motion. So it is the inertia of rest, that because of that the person will get hurt. And the last question, a car weighing 1600 kg moving with velocity given 30 meter per second retards uniformly coming to rest in 20 seconds. Calculate initial momentum and the final momentum. So firstly we'll calculate initial momentum. So firstly understand what is momentum. Momentum is nothing but the quantity of motion present in the body. Quantity of motion present in the body is called as the momentum. Quantity of motion present in the body is called as momentum. It is represented by P, and its mathematical expression we have is m into v. P is nothing but momentum, m is nothing but mass, and v is nothing but velocity. M is nothing but mass, P is nothing but momentum. So over here, m into v initial we have to take. Whenever initial momentum is there, mass into initial velocity you have to take. So which is equal to mass over here is 1600 kg given into velocity initial is given, and that is 30 meter per second. So if you just multiply this, 48,000 kg meter per second. Now kg meter per second, how? Mass has a unit of kg, that is kilogram, and velocity has a unit of meter per seconds. So you will get kg meter per seconds is the unit of initial momentum. Now B, final momentum we have. What is the final momentum? M into V final we have. What is V final over here? It will come to rest, we can say 1600 into 0 meter per second. So if you just multiply this, you will get 0 kg meter per second. So this is the final momentum we have. So initial momentum is 48,000, final momentum 0 kg meter per second. So the main point that you need to remember over here is the note. Body at rest will have zero momentum. So if there is no motion in a body, right? If there is no motion in a body, then we can say there is no momentum. There is no momentum, right? So this is what you need to remember over here. So I hope this is clear. Now, if anyone has any doubt related to any of these questions, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.